In this video, I'm going to go over scale reliability and validity. So just to review, you might remember from class that reliability refers to the extent to which a measure is stable and consistent over time. So what this means is that if the same person takes the same test multiple times, they get the same result. So if you were to take a midterm the first time and then take the midterm again a second time and get the same result, that midterm would be reliable. Reliability also means that two sections of the same class can take the same test and get similar scores. In this case, what we're talking about is two different groups who complete the same measure and get very similar results. When we say a measure is valid, what we're referring to is the extent to which a study actually measures what it intends to measure. So let's say you want to know if you're healthy. If you were to define healthy as being in shape, you could use something like the scale that you see on the right-hand side of the screen. This would be measuring your weight, and your weight may be a good way at getting at whether or not you are in shape. So this scale might be valid. However, if you're defining healthy as the presence of Alzheimer's, so whether or not you actually have Alzheimer's, using a scale like this may not be valid because it's not assessing the construct that you're interested in. When considering reliability and validity, it's often helpful to consider this idea of a target. Your main construct, whatever psychological construct you're interested in, would be the bullseye. Everything else around it is coming close to that target, but it's not exactly the same thing. It might be related, but it's not exactly the same. So when a measure is valid, it hits this bullseye, and it will do so consistently. So when you get a result like this, what you have is a valid measure. Now, it is possible to have a measure that is reliable but not valid. So when a measure is reliable but not valid, what we're saying is that we're getting a very consistent result, but it's not actually hitting the bullseye, or it's not getting close enough to the construct that we care about, so it's not valid. It is also possible to have a measure that is neither reliable or valid, in which case you would see something more like this, where you're getting very inconsistent results all the time. You might wonder to yourself, though, is it possible to have a measure that's valid but not reliable? And the short answer to that is no. The reason for this is when you have a measure that is not reliable, what you're saying is that it's not hitting this bullseye in a consistent way. So it is hitting the target, it might be coming close, and sometimes it might come really close, but it's never actually doing it in a consistent way. So it can't possibly be a valid measure. To illustrate this, let's start by going over some examples. So let's say that you are at the library and you have two clocks that you can refer to. One is your smartphone and one is the clock on the wall at the library. Let's say the first time you look at the time, you see that your smartphone says that it's 2:53 p.m. The clock on the wall, however, says that it's 4 p.m. Let's say you wait a little while and then you check your smartphone again. This time it says it's 2:58, but the clock on the wall says it's 4:05. The thing to note here is that both your smartphone and the clock on the wall are saying that 5 minutes have passed. So they're giving you a consistent result. Let's see if this pattern continues though. So if you were to look at your smartphone a third time, you might see that it says it's 3:08 p.m. You might also see that the clock on the wall says it's 4:15. Now in this case, what you're seeing is that both your smartphone and the clock on the wall are saying that 10 minutes have passed. In this case, the clock on the wall is reliable, but it's not valid. It's reliable because it's giving you a consistent output. So compared to your smartphone, it is telling you the same amount of time has passed. But it's not valid because the time the clock on the wall is giving you does not match up with the time on your smartphone, which you probably trust more anyway since it is connected to the internet. But now let's consider a very similar example, but this time you're comparing your smartphone to a clock at work. So once again, let's say you look at your smartphone and it says it's 2:53. The clock at work says it's 4 p.m. You wait a little while and your smartphone says it's now 2:58. This time the clock at work says it's 4:09. So the thing to note here is that your smartphone is saying 5 minutes have passed, but the clock at work is saying that 9 minutes have passed. Let's say you wait a little while again and you check your smartphone and the smartphone says it's 3:13. Now the clock at work is saying that it's 4:37. The thing to note here again is that your smartphone is saying 15 minutes have passed, but the clock at work is saying that 26 minutes have passed. So in this case, the clock at work is neither reliable or valid. And we know this because the time that passes is not consistent with what your smartphone says. Your smartphone will say that 5 minutes have passed, but the clock on the wall is saying 9 minutes have passed. When your smartphone says 15 minutes have passed, the clock on the wall is saying 26 minutes have passed. So it's in no way reliable. It's not measuring time consistently. And because it's not reliable, we also know that it's not valid. It's not valid because you can't possibly know the time when your clock is not consistently measuring time. So just to review, when we say a measure is reliable, what we mean is that the measure is consistent. When we say a measure is valid, what we're saying is that it accurately assesses the construct that we're interested in. It is possible for a measure to be reliable and valid, and reliable but not valid. However, if you were to say a measure is valid but not reliable, that would be completely inaccurate. It's just not possible to have a measure that's valid but not reliable.